This is the nature of things. The teenage years are a puzzle for every generation. Today's parents are as stunned by the transformation in their children as their parents were before them. Sometimes they make us want to stand up and cheer. Sometimes
you just want to crawl into a hole and sort of ignore it all.
Often, they just leave us shaking our heads.
Being a teenager is probably the most complicated stage of your life.
At their best, they remind us of who we should be. At their worst, they threaten to tear us apart. But love them or hate them, the question is the same. Why are they like that? Scientists are at long last answering that question, and their research is telling us that far from complaining about teenagers, we should be celebrating them. For it is they, the adolescents, who make us human.
Yeah, without teenagers, we'd be short-lived and stupid.
Of all the discoveries made through recent brain scan technology, perhaps the most fascinating, especially to parents, are those describing what happens to the brain during the teenage years. Adolescents, it seems, are not just victims of puberty. In the cystic fibrosis lab at Toronto's Sick Children's Hospital, one volunteer lab assistant was getting a lot of attention in early 2011.
I'm Marshall Zhang.
Not just because of his age,
I'm 16 years old.
but because in his first ever experiment, he made a groundbreaking discovery that had been missed by seasoned researchers.
That's really exciting. It's very exciting, and it means to us that this is going to be a fruitful way to move forward.
To do this, Marshall had to teach himself a complex molecular imaging program,
Definitely a big challenge.
and then trust his results, even though experts said the compounds he wanted to combine would cancel each other out.
And so we carried out the experiment, and on that Friday when we took out the results, not only were the compounds not having to compete with each other, they're actually working together synergistically in creating an effect that was greater than the sum of its parts. So it was almost like seeing 1 + 1 = 3 in front of my face, and that was just mind-blowing.
A remarkable achievement by a 16-year-old, and yet one a 16-year-old brain might just be best suited to make.
Marshall didn't see any limits to applying these methods, whereas, you know, when you're a little bit older and you've got a certain set of what limitations there might be in a particular area, you feel that there's maybe some barriers to moving in a particular direction, but you know, Marshall didn't see any of those barriers.
And in that, Marshall isn't the exception but the rule. To bring a fresh perspective to old problems and challenge supposed limits is the very essence of the teenage mind. And it holds the key to our success as a species. There are many teenage behaviors we like to call typical. We know them when we see them. Some are a parent's greatest pride, others not so much. They can range from awe-inspiring discipline to out-of-control partying to jaw-dropping risk.
I was inspired by watching an old episode of Mr. Bean where he's sitting on the roof of his car because his car's filled with like furniture that he bought at the store, so he drives it on the roof. And I was like, oh, I could do that with a car. It would be super funny. I was holding on to a piece of rebar that was attached to the gas pedal and then steering from behind. So at the very last second, I let go of those and leaped as hard as I could so that I would clear over the box of the truck, the land, and then make it into the water. And yeah, it took a lot of precision and perfect timing, but everything worked out.
I did talk to Trevor about it, and I asked him, Trevor, could you please stop doing this before somebody gets hurt?
Pretty cool, huh?
Well, I guess if you're a teenager. He didn't listen because This is what 17-year-old boys are like. I think sometimes when I'd ask Trevor not to do things, he'd do them just because I asked him not to.
Trevor's desire to impress his peers and attain internet notoriety trumps his mother's concern. But despite her dismay, Trevor's brain, too, carries the secret of humanity's success.
I'm going to use this light to look
As
into your
science
eyes.
looks into the question, why are they like that? Conventional wisdom is dissolving under its scrutiny.
That's perfect.
Hormones, for instance. It's all about the hormones, right?
We often think of teenagers as being driven by their hormones to do things, but actually humans are never really that driven by their hormones to do anything.
Then there's the pain of teenage life, a living hell of self-consciousness, self-doubt, and rage.
Most kids are not depressed, insecure, anxious, and having difficulties all the way through their teenage years. That's a minority of kids.
The media stereotypes have misled us, but this current generation of biologists and social scientists is trying to construct an accurate and objective picture of the teenage brain by looking at its role in human development. David Bainbridge is an evolutionary biologist and author of the book, Teenagers, A Natural History.
Teenagers are this strange, uniquely human phenomenon, and which means we must have evolved them at some stage. And we think that must have something to do with the brain.
Stan Kuchar is a Nova Scotia psychiatrist specializing in adolescent mental health.
So the fact that in our species the brain grows mostly outside the womb makes it uniquely able to adapt itself to the environment that it lives in.
Jay Geed is a neuroscience researcher at the U.S. National Institutes of Health and head of the biggest study ever conducted on normal brain development.
It literally used to be called the black box. So for the past 20 years, we've been using imaging technologies to look at the living, growing human brain.
Dr. Geed's research is part of a multi-year cross-country study of hundreds of children and young adults that will eventually produce a detailed picture of a healthy developing brain.
Hi, Rocky. You doing okay?
Yeah, I'm fine.
Okay, this scan will take about 10 minutes. If you need to come out any time for any reason, just say out, and I'll come in and take you right out, okay?
Already, the broad strokes are emerging, though much remains to be explored.
In a way, we've looked inside and found 1,000 more smaller black boxes, so there's still many, many mysteries.
Teenagers were not invented in the 20th century, but that doesn't mean they've been with us forever. Biologically, they probably came about as a result of a couple of spectacular mutations in the early days of our species.
There were two big jumps in the size of the human brain. One was about 3 million years ago, when it almost doubled from what it had been before. And then about 300,000 years ago, it added on another sort of 50% and became the final 1,200, 1,300, 1,400 milliliter brain we have now.
The extra mass probably made us the smartest of the apes.
It is one of these things where size does matter.
But size alone did not make us human. That required learning how best to use all this new equipment.
We know when humans started taking more than 10 years to grow up. We know roughly when it happened. It was around 300,000-400,000 years ago. And that's pretty close to the time when the brain made its final big leap towards sort of Homo sapiens size. And I think those two go together. I think we needed the teenagers to make the big brain work.
So teenagers were the evolutionary solution to bringing this wonderful new brain online.
Think about outcomes.
From birth until about 11 years, the age of this class, children are busy mastering the fundamental skills of walking, talking, and coordination, and consuming vast quantities of information about the world around them.
And this is where the DNA is. Have you guys heard about DNA? It's like the genetic instructions. That's all inside of here, sort of the headquarters of the cell. And so this by itself, a neuron, isn't really that smart. But 100 billion neurons working together is smart. Right now you have about as many as you'll ever have in your whole life. So by 11, each of your brain cells will be talking to about 10,000 other ones.
Interneuron connections make anything seem possible. And at this age, our strongest characteristic is our curiosity about the world.
You'll get more and more.
Yeah.
someone were to take, let's just say Einstein was alive but he's dying, and someone were to take his brain and put it in his son, will his son have all his father's memories and be like as smart as Einstein?
Yeah, that should work in terms of...
So they're right at the apex now of the potential in terms of all the different directions that their brain can specialize in. And it's such a key time. The brain is just this time of life. It's so built to learn, to change, to adapt to the environment.
Next stop, teenagers. On a signal from the genes, development turns to our brain's latest acquisition,
called the prefrontal cortex. And it's our most human part of the brain. It's most different between us and chimpanzees. It's the latest to evolve, it's the latest to mature. And it's this part of the brain that is really, really busy, not just during the teen years, actually well into the 20s.
It's where we do our thinking and the seat of our unique primate superpower.
It's the part of the brain that allows us to time travel. The prefrontal cortex allows us to consider the past, to consider everything that's happening at this very moment. But it also allows us to go into the future, to wonder about, what if I did this, or what if I did the other? And we can play out these scenarios in the safety of our mind instead of the physical world, where the wrong choice might lead us to break our limbs or really get hurt.
Considering consequences becomes so second nature that adults may forget it's a skill that has to be learned.
It's a critical part of the networks for things like long-range planning, for judgment, for controlling impulses, for organizing and for strategizing. And it's not that the teen brains can't do these things, it's just that it's not as good as it's going to get.
To many parents, it can seem like a long journey, but the destination is worth it. The most powerful brain in the known universe.
Holy mackerel, where did you do that?
The adolescent's job is to integrate this rational, time-traveling prefrontal cortex into the decision-making centers of the older limbic brain. This isn't easy. The limbic brain is emotional and impulsive.
Well, both systems are developing over time. The limbic system actually goes a little bit quicker in the adolescent years, and the cortical system catches up in later adolescence. So that's why we have this phenomenon in adolescence of an increased drive, emotionality, and later on, the more complex cognitive break on that emotionality occurs, and that happens for everybody.
Inside the brain, a furious rewiring project is underway. The prefrontal cortex builds more and stronger connections with the limbic brain, bringing rational messages and toning down limbic impulsiveness. These new connections are incomparably more efficient than the scattered connections of the child's brain.
3,000-fold increase in how fast information can be moved around in the brain.
Meanwhile, thousands more high-speed connections form between areas within the prefrontal cortex as we begin to make sense of the world around us.
So it's like going from a town that has dirt roads linking the different parts to superhighways.
We can see results in athletes, even in the early teens, as the child's impulse just to kick the ball toward the other goal is mediated by practice into a considered strategy that brings theory and experience into play. But the unique characteristic of the human brain, the real secret weapon of the teenage mind, is who's designing it. The architect of this highway system is none other than the teen herself.
This pathway, this traffic that occurs then on these highways depends on what parts are being used.
As teenagers, every move we make, every decision, every experience leaves its mark on our brain. Our skills are not passed on through our genes like a cat's or a bird's, but acquired from our actions in the world. Instead of springing from the brain, our skills are etched onto it in a pattern that is different for each of us, custom designed to meet the world as each of us sees it.
What we have are brains which are basically hardwired to be successful. They're hardwired to be able to adapt to life and the circumstances of life.
So when the climate changed, when we had changes in the environment, the people that survived were the ones that could adapt. So it wasn't just a matter of sort of who was toughest and who was most clever. It was that the brain could change to adapt to the different environmental demands.
And that's why adolescence is so important, because it is the evolutionary adaptational component which leads to our species surviving.
Taking risks, breaking the mold, questioning authority. These are the characteristics of the adaptive mind. We've used it to conquer every climate and landform on Earth. Taking 25 years to grow up has added decades to our lifespan. So,
without teenagers, we'd be short-lived and stupid.
Not every teenager will change human destiny, but every one has the potential. And while creativity doesn't end with the adolescent years, quite often, that's where the seeds are sown.
But you actually look back in history at many of the people we now think of as geniuses, and many of these great successes they had in their 20s or 30s or 40s actually stemmed from a little inspiration they had when they were a teenager.
Day, all week, occupy Wall Street, all day, all week, occupy Wall Street, all day, all week, occupy.
So I do think teenage creativity and the teenage sort of urge for change, I think it's very important for the development of human culture.
If every teen is designing his or her unique mental highway system, what is it that drives each design? Why take one route and not another? Why connect these parts of the brain but not those? In a phrase, what drives our choices? To understand that, we must look beyond the highway project to the churning chemical factory behind it.
A 16-year-old driver died today in a multi-car collision.
The teen years regularly produce a phenomenon that alarms everyone, but surprises few.
Everything you measure is at the top of its game. Your tolerance to heat and cold, resistance to cancer, almost every physical aspect you can measure, you'd say this is the best time of life. But morbidity and mortality go up 300%. Number one by far is motor vehicle accidents. So if you're a teenage girl and die, half the time it's in a motor vehicle accident. 2 and 3 are suicide or homicide, but all the top 10 seem related to judgment or decision making.
Teenagers who crash cars have let their urge to test the limits overpower their still forming judgment centers. Why? What is the payoff that makes risk so attractive?
Have you seen this one before?
No.
No.
I saw one with your buddy up there, but not this. Cool.
Many adjectives are applied to such activities by peers, adults, and social commentators. But to a neuroscientist, they are doing just as nature intended.
Woo! Holy, that was awesome.
Testing the limits of their world in hopes of producing a strong limbic surge of the chemicals called neurotransmitters.
There are all sorts of neurotransmitters, which basically are chemicals that help these electrical signals go from one cell to another.
Neurotransmitters are the communications medium of the emotional limbic system, chemical messengers in its dialogue with the evolving rational cortex.
It's the limbic system that tells the prefrontal cortex how to keep score, what's important, what should the prefrontal cortex be trying to achieve.
In this business of keeping score and building the adult brain, one neurotransmitter stands out from all the rest.
The dopamine system is a really interesting one because what it is associated with is the components of risk, reward, and motivation. And that system really comes on with a bang over the adolescent years.
Dopamine is involved in so many different systems. It's involved in movement, in our motivations, in addictions, our general sense of reward and well-being.
Adolescents seek dopamine because it both fires our motivation and then provides the reward, assuming we're successful.
And so as we make decisions, it leads to outcomes. And if we make a bad decision and it leads to pain or unhappiness, our dopamine levels go down, I said, don't do that again. And that was the wrong call.
You won't be doing that again.
You okay, Trevor?
And if those outcomes are good, our dopamine goes up, and that tells our brain, good job, whatever you just did, that was the right decision. Let's do that again. Let's use those connections again. And so using the currency of dopamine, our environment and our experience gives us feedback.
Because we like the dopamine charge, we repeat the action that created it. In a very concrete way, dopamine drives the shaping of the brain and prefrontal cortex. Factors shown to elevate dopamine levels include loud music and the presence of friends. And surviving harrowing experiences, again, better with friends.
That didn't take much planning. We basically went to the dollar store and bought all these fireworks. We're like, well, what can we do with these? Oh, let's go to the skate park and blow ourselves up with them.
And one of the interesting things seems to be is that the presence of peers increases risk-taking behavior in teens.
Probably one guy by themselves would not have wanted to do it, but there was 5 or 6, and we're like, yeah, this would be so fun because we're all in there. I don't know, it makes you feel safer, I guess.
No adult would be okay with this level of risk, but some risks are definitely beneficial.
If you're going to be functioning as a successful human, you really do have to take risks. So many of the good things that we come in life are because we took risks. And the teenage years are really a time when you can practice this. You can see what taking a risk feels like. You can see what can go wrong if you take a risk. And also you can find out all the wonderful things that can happen because you took a risk and it paid off.
And each outcome, good or bad, leaves a corresponding imprint on the brain. Because the process is the same for any activity, choosing your risk can make all the difference.
You know, going off to work in Guatemala with Habitat for Humanity is good risk-taking behavior because you're going to learn a heck of a lot of great things, and you're going to grow as an individual, and you're going to see things, and you're going to understand things. That's good risk-taking behavior. Stealing a car, not good risk-taking behavior.
Risk is simply the teenager putting himself out into the world.
At the end of grade 10, I sent out a few emails to some professors at the University of Toronto, and I asked them, hey, can I volunteer in your lab over the summer just to see what it's like to work in a research lab?
Even applying for a job, anything which puts you in the way of failure or rejection is a risk.
I sent out more emails.
As when Marshall Zhang decided to get some real experience in a research lab.
I got a list of the entire University of Toronto biochemistry faculty. I looked through the labs and I said, hey, I'm looking for a mentor for this project. Could you mentor me for the upcoming year? And I sent out probably 3 emails a day. And on a good day, nobody would respond. And on a really good day, maybe one person would say no. I was literally down to the last professor on my list, Dr. Christine Baer, a professor at the University of Toronto and at Sick Kids Hospital. And I contacted her and she said, hey, you know what? We'll try and work something out.
We can safely predict from Marshall's behavior that he will end his adolescent years with a brain structure optimized both for solving problems and for the persistence needed to see the process through. And he will have done it by putting his reward system at the service of his conscious ambition. But no behavior is wasted from the brain's point of view. All experience is learning, and as the brain makes more and more connections, even the seemingly chaotic takes on order and direction.
We were inspired by Jackass, and like, this seems like a lot of fun. We can do this for a while. And it slowly grew into more of a love for filmmaking and entertaining and things like that. And so now I'd like to pursue a career more in filmmaking and acting, actually.
As complex as our brain is, its reward system is remarkably simple.
It's the same reward system that's involved in food, in sleep, the sex drive. All of these things kind of tap into a very fundamental part of our brain that says this is worth pursuing to survive or to reproduce. And this system relies mostly on this chemical dopamine.
Any activity that brings success can produce this dopamine reward. Unfortunately for teens, many goals require discipline first and reward later. And this is not something the teenage brain does well.
We know with teenagers, rewards which may be smaller but are more proximal, that may happen soon, are preferred to rewards which can be greater but happen later.
Which leaves them vulnerable to the reward system's Achilles heel, a tiny structure deep in the limbic brain.
The nucleus accumbens is a small part of the brain, but a very important one, because everything that we've ever found to be addictive increases dopamine in this one small part of the brain, the nucleus accumbens. And not just chemicals of addiction, from shopping to behaviors to sex addiction, all those, any kind of version of addiction we have where people keep doing something despite very bad consequences. It's an essential part of addiction, is related to increased dopamine in this one part of the brain.
Instead of all the tedious effort of achieving goals in search of a dopamine rush, drugs make it accessible at a moment's notice.
What happens in addiction is it gets hijacked. That the substances of abuse, they all sort of trick the system into using our brain's own reward system, ironically to ends that aren't ultimately healthy or good for us.
Worse yet, the budding addict is relatively insensitive to the downside of his habit.
They are much more sensitive to positive stimulus than to the aversive effects of the stimulus itself. So that they're much more positive to the high that alcohol gives you than the terrible vomiting that occurs when you drank too much.
Like all other teens, the addict is building her adult brain. In her case, though, one that is wired to make addiction a lifelong career.
This is one of the reasons substance abuse is such a bad idea during adolescence, because it's messing up with the scoring system. And so right at the time when the brain is solidifying these systems and getting the fine-tuning of the reward and punishment systems, introducing substance abuse really couldn't be worse timing.
Is this dark side of dopamine just an unfortunate but random trick of evolution? Or is there some positive reason our forebears were selected for this trait? Is there actually an upside to addiction? Well, yes there is, and it's a thing called love. For centuries, poets and minstrels have rhapsodized over the mysterious power of young love. Alas for them, this mystery too is rapidly being solved.
This is one of our group scans. It's a combination of all 15 people who had just been rejected in love. And sure enough, we found activity in the nucleus accumbens, and this is the brain region associated with craving and addiction. And that proved my hypothesis. I had long believed that romantic love was an addiction, a perfectly wonderful addiction when it's going well, and a perfectly horrible addiction when it's going poorly. And indeed,
although romantic love can apparently strike at any age,
the youngest person that I ever found who was in love was 2.5.
It's in the adolescent years that it takes on the life and death importance of Shakespearean tragedy.
What she said, they were all like, why are you doing
Since
it?
the 1990s, anthropologist Dr. Helen Fisher has been investigating this perfectly wonderful addiction
Are you in love?
in lovers of all ages
Yeah, actually.
and both sexes.
Have you ever had a crush on anybody?
Yeah, a lot.
She rejected the conventional notion that love was just a tool of reproduction.
This is not the sex drive.
They were just too different.
Romantic love is a much more powerful drive than the sex drive. You know, if you casually ask somebody to go to bed with you and they say no thank you, you don't kill yourself. But around the world, the crimes of passion that are linked with romantic love are astronomical. So I had long thought that if we looked in the brain, we would find different pathways are linked with the sex drive than are linked with feelings of romantic love.
In 1998, she teamed up with neuropsychologist Arthur Aaron of Stony Brook University in New York
We've put over 75 people into the brain scanner so far.
to find love's home in the brain.
Well, I certainly expect activity in the ventral tegmental area because that's where we always find it.
And we found some of the basic brain regions that become activated when you're madly in love.
I would expect some deactivation in the prefrontal cortex because
It's the reward system of the brain that becomes activated, which led me to believe that romantic love really is not an emotion. There's lots of emotions involved, but it's basically a drive, an urge, a want, a homeostatic imbalance, a craving to win a particular mating partner.
And what is craving's favorite neurotransmitter? Not hard to guess.
And sure enough, we found activity in cells of the VTA that actually make dopamine. It's what gives you that rush of intense infatuation, the energy, the euphoria, the giddiness, probably even the possessiveness of intense romantic love. Before I put people into the brain scanner, one of the questions that I would ask them was, would you die for him or her? And they would say,
Yeah, I totally would, because she's really nice.
Yes.
they would say yes as if I had asked them to pass the ketchup. I mean, they didn't even think twice about it.
Not that this intensity is unique to teenagers in love.
I've always felt that teenagers had exactly the same feelings in their brain when they were in love as older people.
Happiness,
Okay,
Warm,
excitement,
right?
fun, and comfortable.
fear.
Good.
You're perfectly describing the brain, by the way.
Am I?
Yes, but they don't handle it the same way because they don't have as much life experience.
This becomes critical when that love is yanked away by rejection.
They've never been rejected before. They feel this is the only love that they will ever have. And so they can overweight it and get themselves into really bad trouble.
Deprived of its stimulus, the reward system suddenly quits, leaving the landscape of the mind barren and without joy.
Boys and girls tend to respond to rejection somewhat differently. Young women will fall into a deep depression and either eat constantly or not eat at all, sleep constantly or not sleep at all, and be on the telephone around the clock telling every single friend about it.
I talk to my friends and I complain to them. And sometimes they tell me oh, just forget about it. But sometimes they're like, oh, well, we can fix this.
How do they think they can fix it?
They can talk to him, or they'd be just go talk to her. Why don't you like her? And then he'd just be like, I don't, or whatever. That usually happens to me.
And then what do you feel?
Then I'm just wow, no one. I feel like no one likes me. And then and then I move on.
Young boys tend to experience it very differently.
They tend to drink too much, drive too fast, hole up and watch television, and men are 2.5 times more likely to kill themselves than women are, or kill somebody else.
This is the territory of parents' nightmares. But Dr. Fisher insists such bromides as "it's just puppy love" or "there are plenty of fish in the sea" just don't acknowledge the power of dopamine withdrawal.
I think the first thing that parents, teachers, friends can do for a teenager who's been rejected in love is understand this is not just a child who's whimpering in his or her pillow. This is a profound addiction that has stolen the reward system of the brain, the wanting system of the brain. These people can't stop loving this person. And then you've got to treat it as an addiction. Throw away the cards and letters. Don't write, don't call. Even maybe go to a different school if that's the problem. You don't want your child to go to jail for 20 years. You don't want your child to die over this. You don't want them to lose time in school. You don't want them to turn into a stalker. And so you have to get them through it.
Getting them through it may require time, therapy, and even pharmaceuticals. In this area, Dr. Fisher warns parents to tread carefully.
One of the things that people recommend for depression and for people who have been rejected in love is taking antidepressants, particularly serotonin boosters, SSRIs, things like Prozac or Paxil or Zoloft. And what these drugs do is drive up serotonin in the brain. And that can blunt the emotions, which is actually can make you feel better for a while. They blunt the emotions, they make you less exploratory, they make you more social, and you can actually feel better for a while. But the problem with these serotonin boosters is that they reduce the dopamine system. They jeopardize the dopamine system. And it's the dopamine system that is essential to feelings of romantic love. So if you stay on these serotonin boosters, blunting your emotions, reducing the dopamine activity in the brain, you're going to be less likely, I think, to fall in love in the future. And that's what you really want the teenager to do, is find a new love. Somebody that really loves them. Then they will become optimistic, energetic, and productive again.
As any top 40 chart will attest, heartbreak is a near universal human experience. Most of us get through it and even put it to work, shaping a stronger, better adapted brain.
It's through heartbreak that we learn to adapt. You know, stress is good for us, whether it's heartbreak or cold weather or whatever, because we learn to adapt. If we don't have these negative life experiences, we don't learn how to deal with them. So yes, I had my heart broken, and yes, I adapted, and I'm okay.
For most of our history, the change from one generation to the next has been incremental. This generation is being asked to make a major leap.
We know that brains adapt themselves to the environments that they're in. And the brain of a child today is in a very different environment than my brain was when I was a child. And one of the biggest differences is the impact of digital technology.
But I think that the ability for the digital revolution to interact with this adaptable teen brain that's so good at responding to the challenges is incredibly exciting and a little bit scary.
For at least a decade, adolescents have been embracing this revolution with enthusiasm. And like every generation, they use change to create novel ways to satisfy the age-old drives of survival and procreation. Adapt they certainly will, but just where this will lead can't be predicted, and this is the part that's a little bit scary, especially for parents.
Who here thinks that you know as much about technology and social media as your parents? Would you put up your hands? Hold them up.
What about more? Yeah,
Way more? Okay, I've formulated that question wrong.
Don Tapscott has written 2 books on growing up in a digital world, and he understands parental discomfort.
I mean, this is the first time in human history when children are an authority about something really important. I was an authority on model trains when I was 11. Today, the 11-year-old at the breakfast table is an authority on this digital revolution that's changing business, commerce, government, education, entertainment, every institution in society.
They're putting this expertise to the service of their own priorities, and few things in the teenage mind loom larger than friends.
And there are so few of us in here who can't say that when they get home and open up their laptop to do their homework, that immediately they just type in Facebook to their browser. And for me, it's almost just like, it's like second nature, like it's just what I do.
The phenomenal success of Facebook and the teenage billionaire who invented it speaks right to the essence of the adolescent brain.
One of the areas that we started studying when we were looking at teenagers was the so-called social brain, in terms of what parts of the brain are that system. And it became clear very early, it's the whole brain. There's no one small part of their brain that is dedicated to social interactions. It's pretty much what the whole brain does.
Humans are very unusual in that we have these things called friends. You really don't see friends in other animals, not in the same way. And yet humans have this obsession, and it really happens in a big way in the teenage years. And what do teenagers do with their friends? They just talk to them, and they seem to be driven to do that. It's a very strong force.
Just put up your hands. Who's got under 50 friends on Facebook? Who has fewer than 100 friends? Who has fewer than 500 friends?
600 mark the other day.
Okay, who's got between more than 500? Most of you. Okay.
To be instantly and constantly in touch with 500 people called friends is at once incomprehensible to those over 30 and taken for granted by those under 25. This is human social evolution unfolding before our eyes under teenage leadership. Anyone who doubts its world-changing potential need only reflect on how the methods used to create the hilarious flash mobs of the last decade have matured into powerful organizing tools that played a role in the election of Barack Obama, and more recently, the upheavals of the Arab Spring.
They're an unprecedented force for change.
Exciting for humanity's future? Perhaps, but to parents, just one more source of anxiety.
You know, oh, my friend just broke up with her boyfriend, so I have to go console her, and all of a sudden they're consoling each other on Facebook in front of 1,000 people.
With the internet rapidly becoming universally available and its dopamine charge irresistible, parents might be forgiven for believing that they have lost the battle, become irrelevant, helpless before peers and sinister online forces. Not so, say the scientists. On the contrary.
Now, one of the important things that we actually know about parenting in adolescence, and which makes sense from what we currently know about the brain and its development, is the fundamental importance of parental involvement through the teenage years. Parents aren't finished when their kid is 12.
When I talk with the teenagers in my clinical practice, I'm struck by how often that they actually care a lot about what their parents think and about what their parents' approval. It's not communicated very often.
You know, like a kid's kind of like a sponge, or a teenager's like a sponge. They'll absorb everything and not know that they're taking it in. And it could be very slowly that they start to realize, wow, I actually learned all these things from my parents, and I'm only now realizing it, which is the case with me.
Raising teenagers has never been easy, and that's not likely to change. But adolescence is not a disease, and it can't be cured, no matter how much some parents might wish it could.
Oh my gosh. I've never put myself in a more dangerous situation in my life.
Studying the teenage brain will continue to expand our insights into its fascinating mechanisms. But individual differences guarantee that mysteries will persist, and every family will still have to negotiate
how we survived and why we're the last ape standing. Come on a journey back in time and around the planet to discover the miracle of our species.